Okay, let's keep going. So I'm going to do 4 scenarios. So when you're looking for the area or the probability, you're going to have 4 ways it can be. It can be to the left, to the right, between, and a tail scenario where you have one to the left and one to the right. So here's the calculator guide for it. This is like the kind of the cliff notes for it, but I'm going to show you in the calculator how to do this. It'll help. All right, let's remember though, the standard normal distribution is the bell-shaped, symmetric, and continuous probability distribution with the population mean of 0 and the standard deviation of 1. To calculate the area under a standard normal distribution, aka the probability, you need to know the lower and the upper boundaries as well as the population mean and the population standard deviation. So 4 basic scenarios. Find the area under the standard normal distribution. Okay, so say we're looking at between a z of 1.23 and 1.90, okay, and it's a between one. So the first thing I'm going to do is I'm going to do second FARS, and then I'm going to scroll to the normal CDF function. So then I'm going to enter my information. My lower is going to be my lowest possible value. My highest is going to be my highest value. And then I'm going to do 0 and then 1. So from there, I'm going to put enter a second time. So in some of the older versions, you don't have to worry about that because it's already going to have that for you. So if you see that now, you see I've got everything normal CDF, the lower value, the upper value, the mean, and the standard deviation. And if you hit enter, it actually gives you the answer. So for the area between these two is 0.0806. So let's do another one. Let's do to the right. So to do to the right, then what you're going to do again is the second FARS, normal CDF. And now the lowest value is 1.10 because when you're going to the right, you want that to be your lowest value is where you're starting from. And then the next is infinity. The way that we put infinity in the calculator is 1 second, comma 99. You have to do it in this exact order, and it tells the calculator it means infinity. So your population mean is 0 and your population standard deviation is 1. So you hit paste and hit enter twice, and this is what you get. Again, you might have a calculator that gives you normal CDF, and then you have to put it in this order. So the next one is to the left, where z is negative 0.23. So again, second FARS, then you're going to do normal CDF. And now what you're going to do is you're going to do negative 1 second, comma 99, which gives you, if you see over here, the negative infinity. And then negative 0.23 is your lowest, is the highest value for that one, and then 0 and 1. And then you get your final answer. Remember, it's okay to have negative values in those first two places. So what if it's a tail scenario? You do second FARS, normal CDF, and again, you're going to put in your lower and then your higher population mean and population standard deviation. Okay, you always have to put in your lowest value first and then your highest. If not, you can get a negative probability, which doesn't exist. Okay, so next we're going to do percentile problems. If you have a problem where you're given the percentile, mean, and a standard deviation, you need to put it in the calculator this way. You need to do inverse norm, the area, comma, the mean, and the standard deviation. The area will equal the percentile. So for the 70th percentile, which is the same as saying the top 30th percent, you're going to put 0.70 for the area. If the question asks for the top 30%, I know that 70% of the data is below that. So because the calculator reads left to right, I'm going to put the area in for 0.70. Another example is the 90th percentile is the same as saying the top 10%, so it's 0.90 for the area. Okay, so when you use the calculator, To use the inverse norm function, you need to know the distribution is normal at approximately normal, the population mean, the population standard deviation, and the area to the left of the cutoff score. So here's an example. So suppose ACT composite stores are normally distributed with a population mean of 21.3 and a population standard deviation of 0.1. Excuse me. The university plans to award scholarships to the students whose scores are in the top 5%. What is the minimum score required for the scholarship? So the first thing you do is the second bars, and then you go down to inverse norm. And again, your calculator could be a little different from this one, and I'll do a different video for that one. But as you can see with inverse norm, you're going to need your area, your mean, and your standard deviation. So now, because I want to know the area to the left, because that's how the calculator reads it, I can say the top 5% is the same as saying there's a bottom 95% below it. I know my mean is 21.3 and my standard deviation is 5.1. So what am I going to put in the calculator? I'm going to put 0.95, the mean is 21.3, and the standard deviation is 5.1. Some of you who have the older versions, you'll have to do this by hand, but as you can see here on the screen, that's the way it's done. So then press enter again and the results will come up. So the minimum score for the ACT composite is 29.7. So the top 5% is 29.7 and above. Okay, example 2. The length of pregnancies are normally distributed with a population mean of 268 days and a population standard deviation of 15 days. If we stipulate the baby is premature if the length of pregnancy is in the lowest 4%, find the length that separates premature babies from those who are not premature. Premature babies often require special care, and this result could be helpful to hospital administrators in planning for that care. Okay. Again, I'm looking for a percentage or the amount of babies that will happen this way. So what I need to do is I need to do second bars, inverse norm again, and again, I'm going to need my area, my mean, and my standard deviation. So I wanted to know the lowest 4%. So if you see below in the picture, you can see the lowest 4%. Because it's going to the left anyway, I need to convert 4% to a decimal to be 0.04. So I'm going to put in my calculator 0.04, and then my mean is 268, and my standard deviation is 15. So when I hit enter, it shows the pregnancy length that separates premature babies from those who are not premature is 242 days. And that's what you're looking at with those types of problems. Let's do another example. The diameter bolts produced in a machine are normally distributed with a population mean of 5.2 millimeters and a population standard deviation of 0.03 millimeters. Find the two diameters that separate the bottom 6% and the top 6%. These diameters could serve as the limits to identify which bolts are rejected. Again, second bars, inverse norm. Okay, I had two areas I had to be concerned about, but what I'm going to do though is I'm going to look at the bottom 6%. So since the bottom 6%, I can convert it to 0.06. So I go ahead and put that into my calculator. So when I put it in my calculator, I get my area is 5.16. Well, what about the upper limit? Well, as you can see here, I did the picture again and I show my upper. So now I want to do 0.94 because the top 6%. So again, I put this in the calculator and I get 5.26. So that is the maximum diameter for the bolts produced in the machine shop.